Okay, so you're given three states in the economy and returns for stock A, B, and C. They want to know what the portfolio's expected return is. So the first thing you have to do is get the expected returns in each state of the economy. So for Boom, the return on the portfolio is the weight of A times the return of A, the weight of plus the weight of B times the return of B, plus the weight of C times the return of C. So those are stocks A, B, and C. So the return for the portfolio under a Boom scenario is 25.8% or 0.2580. And again, just making sure you understand this. So for stock C, it's a 0.2 weighting, and the return is given in the book for a Boom economy for stock C of 0.55, so 0.20 times 0.55 would get you that weighted return in a Boom scenario for C. Then you would just add up each of these stocks' weighted returns and come up with a portfolio return, and that's really called a weighted return for a Boom portfolio in a Boom economy. And you do the same thing for the normal economy and the same thing for the bust economy, and you get these returns in these scenarios. So 25.8 in Boom, 12.6 in normal, and in a bad economy, minus 5.2. That makes sense. Obviously, I put this piece of paper up as a PDF, but so I'm not getting the whole thing in because I want to zoom in on what I want to talk about. So the expected return for the portfolio next is basically taking what's given in the book as the probability states in the economy: 15% Boom, 60% normal, 25% bust. And the example I'm highlighting here is 0.15 is the probability of a Boom times the expected portfolio return for the Boom, which is 0.2580. So that's why you're multiplying the probability of a Boom economy by the return you would get in that Boom portfolio. So you do that for each of the expected returns of each state, and you add them together. So, and you can make sure this adds up to 1. You have 0.15% chance here, 0.60%, well, 60% chance here, and then 25% chance for a bust. And they had, as I said many times, probabilities have to add up to 1. So 0.15 plus 0.6 is 0.75 plus 0.25 is 1.0. So that works. And then when you add that all together, you get this expected return over here. I wrote it down. The expected return is based on the probabilities of the state of the economy. Those three probabilities. So, and that's the final answer for that is 0.1013 or 10.13%. Now, we will use this 0.1013 or 10.13% number as the expected return for the portfolio in our variance calculation. It's going to be in every one. There's the first one, there's the second one, and there's the third one. So it is, and I wrote this down so you could study it, will be used in the variance equation, expected return. So as we talked about many times, whatever your observed return is, you're going to subtract from that when you're calculating variance the expected return. So in this case, we calculate or estimate that we're going to get a 25.8% return in a Boom economy, and we're going to subtract from that the expected return that we calculated up here, factoring in all scenarios. So that gets us a difference, okay? We're going to square the difference, and we're going to multiply that by 0.15, because the 0.15 is the probability that's going to play out. That's the Boom probability. Then moving on to the normal scenario, you have a 0.1260 is the expected return we calculated for a normal economy right here. And then you're going to multiply that 0.1260 0.1260 here, you're going to subtract from that, the expected return of the entire probability state, which we calculated as 10.13. And I told you it would be used in the calculation over and over. So we do that difference, we square it, and we multiply it by the probability of normal. And lastly, we do the same calculations for the bust scenario, bust expected return. So the bust expected return calculated above is a minus 5.2 right here. So you have minus 0.520 percent, and in decimal form that's minus 0.052, and you subtract from that the 0.1013, and you square that and you multiply it by the probability of the bust state. And when you do that sum of squares calculation, you get a variance of 0.00992, and to get the standard deviation, you know that you take the square root of that. And whenever you take the square root of a number that's in decimal form, it will get bigger. So you can see that the variance here goes up to 0.0996 for a standard deviation of 9.96%. So that's how you do that one. It's just a little more complicated because you have 3 stocks and you also have 3 probability states. It's similar to the example I worked out in class in the slide 11 for chapter 11's PowerPoint. So this is a step-by-step way to understand how the variance is calculated and standard deviation is calculated for that. Part B is simply asking what's the expected risk premium on this portfolio. And they give you a T-bill rate. And you know that, I've said many times in class that the risk-free rate is a T-bill rate. So simply using a T-bill rate that's given at 3.75%, and the expected return in this portfolio was 0.1013 or 10.13%, you simply subtract the expected return of your portfolio of assets, of risky stocks, minus the risk-free rate, and you take 0.1013 and subtract from that 0.0375, and you get 0.0638 or 6.38%, and that is the risk premium.